Good morning, good afternoon, good evening. Hey, this is Mr. Goodfellow. Good afternoon or good whatever, Mrs. Bryan's class. Hey, I know you guys are looking at the final exam stuff, so I'm going to do questions 1 through 10 on this video. So if you're looking for anything other than questions 1 through 10, you're looking at the wrong video. With that, this is Mr. Goodfellow, by the way. I do teach math over there at Regis as well, so nothing too hardcore. Let's go through and take a look at number 1 through 10 on this one. So number 1 says solve a system for z. So what I'm going to do is try to get everything to try to get rid of everything I possibly can for z. So what I'm going to do in this case, I'm going to take these first two equations, I'm going to add them together and see what actually I can get rid of. So if I try to do that, actually if I do that, the y's are going to cancel because one of them is positive, one of them is negative. So I take these two equations and add them together, it's going to give me, let's see, that'd be negative 2x minus 4z is equal to 16. Okay. So now what I'm going to do in this case is pretty much exactly the same thing, but I'm going to have to do a little bit more work to try to get rid of the z, get rid of the y's on the next equation. Okay, so what I'm going to do now is kind of erase some of the stuff I've done here. I'm actually going to take this top equation here, I'm going to multiply this one by 2, because it's not large enough to try to get rid of this 4 down here. So I'm going to multiply this top equation by 2, okay, and then add it to the equation below. That would be negative 6x minus 4y minus 6z is equal to 22. I'm going to add 4x plus 4y plus 5z is equal to negative 18. If I add these two equations together, we're going to get, let's see, that would be negative 2x, and negative z would give us positive 4. Okay, so if I go through there, nothing too hardcore. So I wrote it over here because now I can take these two equations and I can probably eliminate the x's if I subtract these two equations. Now when you subtract, it's just like adding the opposite. So we're going to say, let's say, make this guy a plus sign, make this guy a plus, make this guy a plus. Okay, so these guys will eliminate with each other. This becomes then negative 3z is equal to, if I'm subtracting here, this is going to give me positive 12. Okay, divide in this case gives me z is equal to negative 4, and that's what I'm actually looking for. So z equals negative 4 does correspond to C as in Charlie on this one. Again, if it was asking for what's x or y, now once you got z, you start plugging it back in. We could plug it back into this one, and we could get x, and we could plug from there, we could plug x and z back into, say, this one, and we can get y from there. So nothing too hardcore, that's how we do this one. All right, moving on, number 2. Okay, again, it's another systems equations. Okay, so I'm just going to set this one up really quick. It says theme park plus transportation, so I'm going to say we'll call that one P plus T for park and transportation is equal to 95.25. The next one is park and hotel. So park plus hotel is equal to 147.00. And then park plus transportation plus hotel equals $182.50. Okay, so now if I was trying to get rid of and do some stuff here, I'm going to actually just take these two bottom equations and I'm going to subtract those two bottom equations, because what I could possibly do there, if I subtract just these two bottom equations, I could get rid of the P and the H, and it could tell me what actually T is. Okay, or I could subtract. It doesn't really matter which one you want to do. If I wanted to, I could subtract top and bottom. Okay, I guess we could do these top two. I guess what I did when I did this one, I did the top two. Subtracted these two guys and then went from that point because it gives me rid of P and T and it gives you what H equals. Okay, so we're going to say P plus T equals 95.25, and then we got P plus, sorry, it's a backwards P. Sorry, P plus T plus H is equal to 187.2. 182.5. Let's try that again. Subtract these guys. Can see P's go away, T's go away. So it's give me then nothing. Take away H would give us H is equal to, let's see, what's that? 87.25. Okay, so that's how much the hotel is going to be. Now, once I have that one, I could take this H and stick it into this equation to figure out how much P is. Once I get that, then I can take that answer and go from there. Okay, so we're going to say then P plus 87.25 is equal to 147. So subtracting this case gives me P equal to 59.75. Okay, now that I've got H and I've got P, I could actually figure out what the heck T is by plugging it back, this one, all the way back into here, or we could plug it into this one, doesn't really matter. Okay, so let's do that. Let's do So P plus T is equal to 95.25. Plug this one right into here. So 75 plus T is equal to 95.25, which gives me T now equal to 35.50. Okay, so now I've got H, I've got P, and I've got T. So the answer is asking for what is hotel and transportation. So I'm going to have to do H plus T. That works out to be 87.25 added to 35.50. Gives me a grand total of 122.75, which is what my answer is, 122.75. Sweet, there we go. That's how we do the first two questions on this one. All right, so let's move on from here. Again, those are all the system questions, so nothing too crazy from that point. The rest of them are all actually pretty easy from here. All right, so here we go. Moving on, question number 3 and question number 4. It says, which of the following graphs shows the function over the domain of blah? Now remember, a domain in this case corresponds to your x values. So what I do in this case is I want to try to eliminate some answers really quick. Notice that this is a closed parenthesis, which means it's going to be a closed dot. This is going to be an open dot, and closed dot. So I need to look for that pattern. Closed, open, open, closed. Okay, so I'm looking for closed. Nope, that one's automatically wrong. So closed, open, open, closed. That one looks pretty good. Okay, put a check mark there. Closed, no, that one's open. That one's wrong. Closed, open, open, closed. Okay, so it's either going to be B or D in this case. So that's what we got for here. Life is looking pretty darn good. Now, the next thing I need to notice is actually, does it follow and does it go actually where I need it to go to? Does it actually go out to the numbers we need to? Okay, so in this case, I'm going to start at -3. Okay, I'm going to start at -3. I'm going to end at +5 on the x value for domain. Okay, so does this one go all the way out to -3? It sure does. Does it end at here at +5? No, it doesn't. It actually ends here at +1. Okay, so that one is wrong. This one, it starts at -3 and ends all the way out here at +5. Wham, bam, that's my answer. You're good to go. Okay, that's all we had to do. You have to first look for the pattern and then just make sure you actually go out as far as you need to. All right, question number 4 sets up pretty much exactly the same way. Okay, so pretty much exactly the same way. If you guys notice, all of the solutions are exactly the same for this first equation. These first equations are all exactly the same except for the C one. Now notice in this case it goes through -5, which means the number on the end should be -5. That automatically tells me that C is automatically incorrect. Okay, so now from here, we should be able to see if we can eliminate something else. Okay, notice in this case is going to be open and open, which means those guys have to be an open or got to just be less thans and less thans. So second one's got to have a less than and less than, loving it, less than, loving it, less than or equal to, less than or equal to. No, that's actually wrong because this guy would actually be a closed point. Okay, so now we've eliminated, now it's either A or B. Okay, now we go from this point and see the rest of it. Okay, so now we got to try to figure out what the heck the rest of this thing is going to be. Okay, we look at this last equation. Is it correct? Let's see. I think I can eliminate this top equation. Let's see if I look here. Even though this part looks correct, this value for -1/3 of x. Okay, if I do the slope, it's going to be up 1, 2, and over 1. So it actually has a slope of 2. Okay, so its slope in this case is 2, not -1/3. That one's wrong. That B has to be my answer because it does have a slope of 2. Sweet, that's how we do questions 1, 2, 3, and 4 so far. All right, moving on. Question number 5. Okay. Now it wants us to graph this function. Okay, again, nothing too hardcore. We're just going to kind of take a look at the graph really quickly. One thing I do know, a couple things right off the bat, is you could just kind of zero in on this piece really quickly because I know that guy is a -x², which means I know my graph has to open down. So it's going to be like an upside down U. So I'm looking for all the ones that have upside down U's. That one looks good. That one's wrong. That one's wrong. That one looks good. So automatically know that B is wrong and C is wrong. Those guys are automatically incorrect. Now from here, we could actually eliminate a couple other things really quickly. Realizing that this slope is a negative slope, and a negative slope means it looks something like this. Okay. This one actually has the correct slope because that is a negative slope. This one actually has a positive slope. So that one is incorrect, so there's my answer, A as an apple. Don't have to actually do any of the graphing stuff here. We just have to kind of just look at and go from this point. All right, moving on. Question number 6. Question number 6 is create this table represented on the graph. Now this is a step function. Now if we go to notice, this is open and then closed. okay, which means I'm looking for opens and closed, which means I need to look for something that is less than, and then a less than or equal to. So I'm just going to look at all those first. So these guys are all less thans. This one's all less than or equal to's. That one looks pretty good. Less than or equal to's, automatically I know that B is incorrect. Okay, less thans or equal to, less thans, just less thans. No, that would actually be open, open. So that one doesn't work either. So automatically those two guys are wrong. Now the next thing I notice is this guy actually travels all the way out to 1 before it jumps. Okay, so it travels all the way out to 1 before it actually jumps. So this one travels to 1 before it jumps to the next one. This only travels to 0.9 before it jumps. That one is incorrect. And there's my answer. It should be A as an apple. Again, all you're looking for is just looking at the graph to see which actually makes sense. All right, so from here, moving on to question number 7. It says identify the domain and range. So again, domain is X and range is Y. Okay, so a couple things are off the bat. I know off the bat is what kind of equation is this going to give me? This is going to give me a U-shaped graph. Okay, this one's going to move it this direction, and this one's going to move it up. Okay, so it means it's going to change the range. So the range in this case is going to have to deal with something with this 1/9. Okay, so the range is going to have to be something with that 1/9. So I'm going to look in the ranges and find out what something's going on with the 1/9. That doesn't have a 1/9 in it. That doesn't have a 1/9 in it. That doesn't have a 1/9 in it. That's the only one that has a 1/9 in it. Wham, bam, you're done. Okay, that's all we had to do for this question. Okay, if you need to totally stuck, you can always graph it on your calculator and move on. I'm just trying to save as much time as you possibly can because you don't have a lot of time on this test. All right, moving on. Question number 8. It says, given this function is translated, da 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 da. So first thing on the bat, what does this graph look like? X to the third? It looks something like this. Okay, so now we're going to look at what is its domain and range. Okay, so it's like, what's the domain and range if you move this thing? Well, the domain in this case is going to be, again, negative infinity to positive infinity. Okay, and the range in this case is going to go, again, negative infinity to positive infinity. So regardless if I move this thing up or down, left or right, flip it over, don't really change anything, that part is never going to change. Okay, there we go. That's the only one that didn't change because that even moving this thing left, right, up, or down doesn't change what the graph looks like as you go. All right, so moving on, question number 9. It says that the graphs are translated, da, 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 da. So it looks like we have a graph that looks something like this guy right here. Okay, if I put my little point right here, we're going to move this guy translated 4 units to the left. So we're going to go, let's see, that happens at -1, -2, -3. We're going to go to the left, 1, 2, 3, 4. That would actually put us at -7. The only one that has a -7 in this case, or the opposite, is this guy right here. That is my correct answer. Okay, that's all we had to do in this case. And again, 5 units up, okay, from this -2, we're going to go up 1, 2, 3, 4, 5. So it's got to end at +3 if you're looking at there. The other one has a +3 on the end of it as well. Blam, you're done. That's all we had to do. Okay, so you're just looking at the graph and just moving it in your head, or if you need to, you can count it just like I did. All right, last one, question number 10. It says, which one of them has a graph that's positive? Now, graph meaning positive means its y coordinate is positive. Okay, so I'm going to look over here at my graph. I'm just going to highlight on my graph the part that's actually positive. So from here all the way over to there, and from this point on. Okay, those are the only times that the graph is going to be a positive solution. Okay, that happens from -3 to 0, and then from, it looks like a little bit between 2 and 3, so like 2.5 to infinity. Okay, so let's see, that one looks like it's going to happen from -3 to 0. Okay, check, check. A little bit more over there to positive infinity. Oh, look at that. First one I checked is the correct answer. So that's how we do questions 1 through 10 on this test. If you get questions or if you don't understand something like this again, watch this video again. No big deal. With that, guys, I'm out of here. Peace. I'll catch you on the next one.